Okay, I'm going to do a couple examples of angular and linear speed. These ones are a little trickier. This one says a ceiling fan has 13-inch blades, so the radius of the circle of the fan is 13 inches. Suppose the fan turns at a rate of 48 revolutions per minute. Find the angular speed of the fan in radians per minute, and then find the linear speed of the tip of the blade in miles per hour, using the fact that 1 mile is 5,280 feet. Do not round any intermediate computations and round your answers to the nearest whole number. So when I am working this problem here, a couple things that I need to know is V is my linear speed and W is my angular speed. So my linear speed is equal to the radius times the angular speed. My angular speed then would be equal to the linear speed divided by the radius. I've just rearranged the formula depending on what I'm looking on. 1 revolution is 2 pi radians, and we're going to use that on the first part A of this problem. So if I do part A of this problem here, first thing we need to do is find the angular speed of the fan in radians per minute. We know that this fan is turning at a rate of 48 revolutions per minute. So I'm going to have 48 revolutions per minute. I want to change that into radians per minute. It's already in the minutes, so that's okay, but I've got to change the revolutions. I know that the revolutions, 1 revolution was equal to 2 pi radians. So since my revolution's on top, I'm going to put the revolutions on the bottom. 1 revolution was equal to 2 pi radians, and so that would go on top. When I multiply, I'm going to take 48 times 2, which gives me 96 pi. The revolutions would cancel, so I would have that in radians per minute, which is the units I want to have. But I want to calculate this to the nearest whole number, so I have to go ahead and multiply by pi. Now you don't want to round pi off too far, otherwise you will get rounding errors. So look for the pi button on your calculator. It's towards the bottom, and use that pi button. If you can't find the pi button, if I calculate pi here, it is 3.14159. Don't round it off any farther than that. 96 times 3.14159. But best bet, use the pi button on your calculator so that you don't get rounding errors. But otherwise, carry it out at least that far when you're doing your calculations. I'm going to do the pi button on my calculator. So I'm going to take 96 times pi, and I get 301.592. 301.592.8. It really won't matter that far because I'm rounding off to the nearest whole number. And since I'm rounding to the nearest whole number, I'm going to round that off to 302. So 302 radians per minute. And that's going to be my part A answer because I wanted my answer in radians per minute. Part B, we're finding the linear speed of the tip of the blade in miles per hour. Again, the linear speed, if I slide this up, is equal to the radius times the angular speed. We found the angular speed here, but we don't want to do any rounding, so we want to use the 96 pi. So V is going to equal my radius, which is 13 inches, times my angular speed, 96 pi radians per minute. And so in this case, I end up taking 13 times 96 times pi. So if we do that, 13 times 96 times pi, again, I'm going to use the pi button on my calculator, I get 3,920.70762. I'm not going to round, so I'm going to leave that. 3,920.70762. I'm going to write it all the way down so I don't get any rounding errors. And that is in inches per minute. So since that is in inches per minute, I have to change this into miles per hour. First of all, I'm going to change the hours because that's a quick calculation. In this case, I know there's 60 minutes in an hour, so I'm going to take this times 60 minutes in 1 hour. Notice my minutes were on the bottom here, so I had to put them on the top so that I can cancel out those labels. So there would be my changing into hours. I also have to change the inches into miles. I'm going to have to do that in a couple steps. I'm going to put the inches on the bottom. 12 inches is 1 foot. And then I have to change my feet into miles. So the feet are going to go on the bottom. 5,280 feet in 1 mile. And now I'm going to have my labels end up because I can cancel out the inches. I can cancel out the feet. And I have miles per hour. So doing my calculation, I still have my 3,920.707632 on my calculator. I'm going to times that by the 60, which is 235. I'm going to write that down here. I'm going to slide this up a little bit. 235,242.4579. Again, I don't want to do any rounding, so I'm just going to leave that great big number, write it down. On the bottom, I have to take the 12 times the 5,280. 12 times 5,280 is 63,360. 63,360. Now I'm going to go ahead and divide. So 235,242.4579 divided by 63,360 gives me 3.712. 3.71279. Again, I want to round that off to the nearest whole number. So when I round that off, I'm going to round it up to 4. And now my label is in miles per hour, which is what they wanted us to have on the question. So my part A answer was the 302 radians per minute. My part B answer, the 4 miles per hour. All right, let me hold this up so you can see this a little better. It says Saturn has a diameter of 74,900 miles. As the planet rotates on its axis, the point on its equator travels 527,787 miles per day. Wants us to find the angular speed of the point on the equator in radians per day, and then find the number of rotation the planet makes per day. So again, if I am doing this, I have to use my formula here. My linear speed is equal to the radius times the angular speed. And so in this case, we know the angular speed because we know that it's a point on the equator and it's rotating. And so the angular speed is going to be the linear speed divided by the radius. And so if I go ahead and find my pencil again here, we know that the point travels 527,787 miles in a day, per day. We are going to take that and we are going to divide it by the radius. Well, when I divide it by the radius, I'm going to invert and multiply. So what I end up doing is putting 1 over the radius. And so if I were putting the radius on the bottom of my fraction, so my radius of my planet, I guess I would say, is half of the diameter. Well, the diameter there is 74,900 miles. So I have to take my 74,900 and divide it by 2 so that I have the radius. If you can see that, I'm going to divide by 2. My radius then is 37,450 miles. So when I divide that by 2, the radius was 37,450 miles. So when I cancel the miles and the miles, what I end up doing is I'm going to divide. So I am going to have 5,000 or 527,787 divided by 37,450. And so I get 14.093. Rounding that off to the nearest whole number, then I am going to have 14 radians per day. And so that first answer that I have is approximately 14 radians per day. Second part of this, find the number of rotation the planet makes per day. And so I am going to have to find what the angular speed is. The angular speed is approximately 14 radians per day, but again, we don't want to end up rounding, so we're just going to use this fraction that we had up here, 527,787 divided by 37450, and that's in radians per day. And so we're just going to leave it as a fraction when we're doing our calculations for the second part of this instead of rounding this off. So we want to find our answer in rotations per day. It's in radians per day. Well, we know that one rotation is equal to 2 pi radians. So then we can cancel out the radians there. And so what we're going to end up doing here is taking that 5,207.87 and dividing it by 3,700,450 times 2 pi. So on my calculator, I'm actually going to do that bottom calculation first. 37,450 times 2 times pi. I get 235,305. And so I'm going to slide this up here. 527,787. I'm going to divide that by 235,305.2898. And so on your calculator, you have an answer. You can do second function answer, or you can type that in. So I'm going to take 527,787. I'm going to divide it by the bottom number. And when I enter there, I end up with 2.2429. 2.242988, so forth and so on. You really don't have to carry it that far because you're going to round that to the nearest whole number. So when I round that off, I'm going to round it off to 2. So 2, and that would be in rotations per day, which is what we wanted. And so our part B answer is 2 rotations per day. The third problem here says a cyclist is riding a bicycle whose wheels have a diameter of 20 inches. Suppose he's traveling at 16 miles per hour. Useful fact, 1 mile is 5,280 feet. Write the angular speed of the wheels in radians per minute, and then the number of revolutions the wheel makes per minute. So, again, we're going to first of all find the angular speed of the wheels in radians per minute. We know that the bicycle is going at a rate of 16 miles per hour. And so since the speed is in 16 miles an hour, we have to convert that into radians per minute. So cyclist speed is 16 miles per hour. We want it in minutes, so I'm first of all going to change that into minutes. We know that 1 hour is 60 minutes. So that'll cancel out the hours. So now I have it in miles per minute. And we want to change that into radians per minute. We have it in miles per minute. And so we have to change our minutes into inches because the wheel diameter is in inches, and so we have to change it from miles into inches. And so we know that 1 mile is 5,280 feet. We know that 1 foot, or not 1 foot, yeah, 1 foot is 12 inches. So in order to do that calculation, we're going to multiply by the 5,280 and the 12 inches there. So my feet will cancel, my miles will cancel, and I end up with inches per minute since this is in inches. So I'm going to do that calculation here quick. If I grab my calculator, I'm going to take 16 times 5,280 times 12, which is 1013760. 1010360. And on the bottom, the only thing I have is the 60. So I'm going to go ahead and divide by 60. And I get 16,896 inches per minute. Now we know that the bike wheel is has a diameter of 20 inches. So again, since they gave me the diameter, I have to divide the diameter by 2. 20 divided by 2 means 10 inches is our radius. So what we're going to do is we're going to take that linear speed and we're going to divide it by the radius of the circle. Again, when I'm dividing by the radius, I'm going to do the reciprocal. So I'm going to do 1 over the 10 inches, and then the inches will cancel out of there. And so I end up dividing that by 10. And so when I divide that by 10, I get 1689.6, moving just my decimal one, or you could use your calculator. And then I have to go ahead and round that off to the nearest whole number. Since this is an 89.6, I'm going to round the 89 up to 90. So 1,690 radians per minute is going to end up being my answer. 1,690 radians per minute. All right, the second part of that problem wants you to find the number of revolutions the wheel makes per minute. The revolutions per minute. This previous answer was in radians per minute, but because I don't want to do any rounding, again, I'm going to go back up here to this answer that came out nice at the end and didn't have a million decimals. Otherwise, we just put the fraction in and use the 16,896 divided by 10. But since it came out nice, I'm going to go ahead and use that. 1,689.6 radians per minute. So this one we don't have to do a whole lot of conversions on. It's already in the minutes. We just need to change the radians into revolutions. We know that 1 revolution is 2 pi radians. And so 1 revolution over 2 pi radians. And so when I do this calculation, what I'm going to end up doing is taking my 1,689.6 divided by 2 pi. And when I divide that by 2 pi, again, I don't want to do any rounding. Whoops, trying to move that there. I don't want to do any rounding, and so I'm going to use my calculator, and I am going to calculate my 2 pi first. 2 times pi is 6.2831, so forth and so on. I'm going to take the 1,689.6 divided by that answer, so I don't have any rounding. 1,689.6. Second function answer. Oops, I forgot to do the divided by. Divided by second function answer. And I end up with 268.908, so forth and so on. I'm rounding this off to the nearest whole number, so I'm going to round that off to 269 revolutions per minute, and then that's going to be my part B answer.